Alright, these are 1-5 notes on rotations. Your objective is you'll be able to rotate a two-dimensional figure about the origin 90 degrees, 180 degrees, and 270 degrees. You're also going to rotate a two-dimensional figure about the selected coordinate 90, 180, and 270 degrees. Rotations, you've seen them all around in this world. Anything that's a circular motion can be considered a rotation, like a wheel in a car or at a carnival. Rotations also are involved with speed. Like on the car, you have miles per hour, and you also got rotations per minute. Rotations and circumference of the circles, those are some of the information you're going to need to know. We have three components. In rotations, we have direction, whether it be clockwise or counterclockwise. Now, just like on a clock, got the hands of a clock. Clockwise is going in this direction, like the hands of a clock. They're rotating in that direction. Counterclockwise means they're going in the opposite direction. So if you have a clock and you got the hands counterclockwise, is if the hands of the clock are going backwards. That's counterclockwise, going in that direction. Degrees involves 90, 180, 270, 360. Well, 90 degrees you already know. It's like the 90-degree box. So if you rotate a hand and now it's going perfectly up compared to perfectly right, that's a 90-degree rotation. 180 degrees, if an arrow's going this way, 180 degrees, it rotates and it's going completely in the opposite direction. 270 degrees, that's like 3/4 of a turn. So if it's an arrow facing right, it's now facing down. That's 270 degrees. 360 is one complete spin. So if you were to stand up out of your chair and you spin completely looking in the same direction as you start and finish, that's 360 degrees. And the other piece of rotations we have to consider is the center of rotation. Where exactly is the middle of this rotating point? Alright, let's talk about rotating a figure 90 degrees about the origin. So aka rotate around the center of the graph. So the center, right there, that blue point is our center of rotation. We have our airplane. This airplane's going to be spinning around. If we wanted to rotate it 90 degrees, so going from here to over here, I accidentally did clockwise. I meant to do counterclockwise, so going from here down to here. A counterclockwise rotation of 90 degrees. We could use this algebraic coordinate xy goes to negative y comma x. So whatever is in the first position of the coordinate then goes into the second position. And whatever's in the second position goes into the first position, and you change its signs. For example, if you have 3, 4, that will get rotated to negative 4, 3. That's if we're rotating this coordinate 3, 4, a 90-degree turn. Counterclockwise, that is. Let's practice this. So we got this black figure here, this not polygon, this four-sided figure, polygon. And we gotta rotate it 90 degrees counterclockwise. So to do that, we identify each coordinate. T is 3 to the left, 2 up. So T is the coordinate 3 to the left, so negative 3, and then positive 2 for 2 up. To change that coordinate, negative 3, 2, we flip-flop the x and the y, so we 2 and negative 3, and we changed the y value. The original y value, that is. So positive 2 turns into negative 2. So negative 2, negative 3. Right here, that blue dot is t prime. Now, we gotta rotate the letter u. U is 1 to the left, 2 down. So negative 1, negative 2. Just a reminder, the formula is negative yx. So we change the y value sign and we put it in the front. So negative 2 becomes positive 2. And then we move the x value into the second position. So we have 2, negative 1. So 2 to the right, down 1. This is our u prime. Now our v, 1 to the left, 5 down. So v is negative 1, negative 5. Our v prime, we flip-flop them. So the negative 5 becomes now positive 5 and goes in the front. And that first position, negative 1, goes into the second spot. So it'll be positive 5, negative 1. So 1, 2, 3, 4, 5, and negative 1. This is going to be my v prime. Last but not least, our s. Our s is 1, 2, 3, 4, 5, negative 5, negative 2. So negative 5, negative 2. This is our s. So our s prime, negative 2 turns into positive 2, and negative 5 goes in the second position. So you have positive 2, negative 5. So positive 1, 2, down 5. Right here is my s prime. You connect those dots, and then we successfully rotated that figure 90 degrees counterclockwise. This is a prettier picture of it. Alright, let's look at number 2 here. Let's rotate this black trapezoid 90 degrees counterclockwise. So it's the same formula. So xy, it goes to negative y comma x. I'm going to type things up here, make it a little bit prettier. So L is 1 to the right, 5 up. So L is 1 comma 5. So then L prime, when we flip-flop them, it becomes negative 1 comma, negative 5 comma 1. So L prime, negative 5, positive 1. Right there is our L prime. Our K is 1 to the right, 0 up, down. So K is 1 to the right, 0 up, down. So K prime is going to be negative 0 or 0. And then 1 for the 1 up. So right there's our K prime. N is 5 to the right, 1 up. So when we do change it up, we do for N prime, it comes negative 1 comma 5. There we go. So negative 1, 5. So 1 to the left, 5 up. That's our N prime. Last but not least, our M M is 5 to the right, 2 up, so that's 5 comma 2. So M prime is gonna be negative 2 comma 5. 2 to the left, 5 up. That's our M prime. Connect them up. Oops. There we go. There's our picture. So this black trapezoid just got rotated 90 degrees counterclockwise, and it turns into the blue. Here, there's a little bit prettier version. Alright, so this one is a rotation of 90 degrees counterclockwise about the origin. So our point of where we're rotating everything from is from the origin, so that's why I count from the origin, because that's our reference point. So y is 1, 2, 3, 4, 4 to the right, 3 down. So y is 4 comma 3. So then y prime is going to be negative 3 comma 4. I'm going to type them all in first. Z is 4 to the right, and then 5 down. 5 down, so that's a negative 5. That's supposed to be 4, negative 3. So that's really, y prime is supposed to be 3, 4. Z prime, when we flip it, it turns into 5 comma 4. X is 2 to the right, 4 down, so 2 comma negative 4. So X prime is gonna be 4 comma 2. And W is 2 to the right, 5 down, so 2 comma negative 5. So W prime is gonna be 5 comma 2. We graph those coordinates. So 3, 4, 1, 2, 3, 1, 2, 3, 4. So that's my Y prime. My Z prime, 5 to the right, 4 up. X prime is 4, 2. And 5, 2 is my W prime. Connect them up. Let me see our little figure. Got rotated 90 degrees counterclockwise. And that's what our answer looks like. There's the pretty version. Alright, let's do one more before we change things up. Rotate this black polygon 90 degrees counterclockwise. A point from our reference, our center of rotation is right there, our origin. So we got U is 0, 3. So U is 0 left, right, comma 3 up. So U prime is gonna be negative 3 comma 0 according to our formula. Our X is the coordinate 3, 1. So it's gonna be negative 1 comma 3 is our X prime. Our W is 4, 4. So our W prime is going to be negative 4 comma 4. And our V is 1, 5. So our V prime is going to be negative 5 comma 1. We graph those coordinates. So negative 3, 0 is right there. Negative 1, 3 is right here. negative 4, 4, right there, and negative 5, 1, right here. You connect them. So that's a pretty. And there's our rotated figure, count 90 degrees counterclockwise. Remember, you should label these two. So U prime is right here, X prime is right here, W prime, and V prime. All right. So the next rotation here is 180 degrees about the origin. The formula for that, usually you take your coordinate x, y, and you just change the signs for all these 180 degrees rotations. Whether it be counterclockwise or clockwise, it's the same. You just change the signs. So let's look at here at number 5. I'm going to rotate this figure 180 degrees about the origin. U is at the coordinate 0, comma, negative 2. So U prime is going to be 0, comma, 2. S is the coordinate negative 3, negative 4. So S prime is going to be at 3, 4. T is at the coordinate negative 4, 1. So T prime is going to be at the coordinate 4, comma, negative 1. Then we plot these coordinates, 0, 2, so 0 left, right, 2 up. There's our U prime. S is 3 to the right, 4 up. So we got S prime, and then T is 4 to the right, 1 down, and that'll be T prime. So we successfully rotated that black triangle into the orange triangle, 180 degrees about this origin. So the center of rotation is that origin right there. That's a key point to remember. Okay. Let's rotate this. Now our center origin is right there in the middle of the picture, so it's going to make things a little bit weird. It's going to rotate on itself. It's going to be a little bit different compared to what we've been doing. So our coordinate U is negative 1, 3. So U prime is going to be the coordinate 1, comma, negative 3. S is negative 1, negative 2. So S prime is going to be 1, comma, 2. T is negative 3, comma, 2. So T prime is going to be 3, comma, negative 2. And V is 3 to the right, 0 up, down. So V prime is going to be negative 3, comma, 0. We graph those coordinates, and we're going to see that it's going to fall right on top of each other. So 1 to the right, 3 down. There's our U prime. 1 to the right, 2 up is our S prime. T prime is 3 to the right, 2 down. And negative 3, 0. There's our V prime. We connect them. Those orange ones, and you see that rotated on itself. So it's okay if they overlap if the center of the origin or the center of rotation is inside the figure or even on the figure. Alright, so this is the end of part 1. Next up we'll do part 2 here. Alrighty.